We're going to do a two-part review of chapter 1. So I'm going to split it into half, and we will do the first review today, and then we'll do the second review on Tuesday of next week. And then Wednesday, you will have your test. So the test will be online. I'm not sure how many questions it will be yet. It's going to be one of my tasks for the weekend. I want to make sure that you are tested on the things that I've taught and only on the things that I've taught, just to make it a little bit easier on you. So the test will be at gomath.grps or gomath, which is at learn.grps.org, and it'll be in your to-do folder next Wednesday. And then we will go from there. So today's review of chapter 1 is going to go over place value and patterns, place value of whole numbers, powers of 10 and exponents, and multiplication patterns. I do have one video on YouTube that I'm going to share with you through it. There are 9 slides, well, technically 8 because this is just a cover slide, and I'm going to do 2 slides for each skill there. So 2 slides for place value and patterns, 2 slides for place value of whole numbers, 2 slides for powers of 10 and exponents, and 2 slides for multiplication patterns. And then on Tuesday, we'll do another review very similar to this, and it will be of the other half of the chapter. All right, well, let's get started while we have the time. All right, so place value and patterns. Remember way back at the beginning of the I'm going to use red for most of this today. Remember way back at the beginning of the chapter, we talked a lot about how the base 10 blocks are related to each other. And as we go from 1 to 10, 10 to 100, and then 100 to 1000, each place is 10 times bigger. So 1000 is 10 times bigger than 100. 100 is 10 times bigger than 10, and 10 is 10 times bigger than 1. Now, something that we didn't talk a lot about is the relationship between multiple steps, and we'll do that today. So if you look, I've written right here, I've written 5,550 and 5. So 50 is 10 times more than 5. 500 is 10 times more than 50, and 5,000 is 10 times more than 500. But what if I asked you, how many more times is 500 than 5? Well, a really quick way you can do that is compare the zeros. There are no zeros for 5, but there are 2 zeros for 500, so it is 100 times larger. It's also 2 jumps. 1, 2. If we were using base 10 blocks, it would be 2 jumps. So you can have 2 zeros there. They are related. Now, what if I asked you, what's the relationship between 5 and 5,000? Well, again, compare the zeros. There are no zeros on 5, but there are 3 zeros on 5,000. So 3 zeros tells you that it is 1,000 times bigger. And I know that it's 1,000 times bigger because 5 times 1 is 5, and it stays a 5 whether it's here or here. Now, something else that I want to talk about when it comes to these place values is when we go the opposite direction. So when we go from a big number down to a small number, we are showing a part of it. And the way that we can show a part of it is by writing it like a fraction. So if you can tell me that 10 is 10 times as much as 1, you should also be able to tell me that 1 is 1/10 of 10. And that's true because if I do 10 plus 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 10, I'm going to have 10 ones, and only one of them is 1/10. The same is true if we are going backwards on this one here with the 5,505. So we are, it sounded like a number, but those are just all the numbers that I said together. So 5,000, we said, was 10 times as much as 500. Now, if I go the other way, 500 is 1/10 of 5,000. So I want to make sure that you know that it goes both ways. If the number is getting bigger, then it would be 10 times, or a multiplication of 10, 10 times, 100 times, 1,000 times. Or if we're going smaller, it could also be 1/10. So with that being said, the 1/10, it looks kind of like that, or like this one here. What I want to show you is, let me get a lot of this out of here. I want to show you this. 500 10 times. 3, 4, 5, 6, 7, 8, 9, 10. Right? So I wrote the number 500 10 times. Now I'm going to count by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Right? There are 2 zeros on each one. So 500 10 times is going to give me 5,000. But if I'm only talking about one of those, that's one of the 10 500, so 1/10. So I wanted you to see that. Let me see if I can get rid of all of this, because I want to go down to the numbers that I have on the bottom as well. So when we're talking about 1/10 or 1/100th or 10 times or 100 times, we can go up quite a few place values. So we can go 10 times 3 is 30. 30 times 10 is 300. 300 times 10 is 3,000. 3,000 times 10 is 30,000. 30,000 times 10 is 300,000. And 300,000 times 10 is 3 million. Now, it can also go the other way. 300,000 is 1/10 of 3 million. 30,000 is 1/10 of 300,000. 3,000 is 1/10 of 30,000. 300 is 1/10 of 3,000. 30 is 1/10 of 300, and 3 is 1/10 of 30. Again, if I write the number 3 10 times, and I count by threes, I have 3, 6, 9, 12, 18, 20, 20. Nope. 3, 6, 9, 12, 18, 21, 24, 28. I did it again. Oh, get it together, Witkowski. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So if I'm only talking about one of those, I'm talking about one of the threes, but there are 10 there, so it is 1/10. Now, just like I was asking you before, let me see if I can get rid of a lot of these. Control Z is a beautiful thing on this Jamboard. I said, what's the relationship between 3 and 3,000? It's 1,000 times bigger, right? And we know that because 3 times 1,000 is 3,000. Now, if we go the other way and I say 3 is what of 3,000, it's still the same number of zeros, but now this time it's on the bottom. So it becomes a fraction, and it's not 3,000s, it's 1,000s. Okay, so that is just a quick little review. I have 2 pages, I think, for this, maybe this page and one other page. So I would like to go through these. So let's do each one 10 times and then 1/10. And it's always going to be of the number that's listed under the number column. So we're going to go back to that number for both steps of that. So let's do the first one. It's 10. What is 10 times as much as 10? Or 10 times 10? The answer is 100, because 10 times 10 is 100. Now, 1/10 of 10, remember, if we say 100, 10, 1, right? we want to know what 1/10 of it is. So if we start at 10 and we go back, it's going to be 1. Just like I showed you on that last slide, and I can show you for this next one, we have 3,000. Well, what is 10 times as much as 3,000? If we start at 3,000, which is here, and we go up 10, that's going to take us to 30,000. So I can go back to my chart and I can type in 30,000. Then, if I want to know what 1/10 of 3,000 is, what I would have to do is I'd have to go the opposite direction. So if I go back a slide, we start at 3,000 again, but this time we're going to go backwards. 1/10 of 3,000 is 300. Okay. I don't have a slide like that I can bounce between for all of them, but I wanted to show you because it was on there. So 1/10 of 3,000 was 300. Now, what about 800? What is 800? What is 10 times as much as 800, or 800 times 10? We're going to put an extra 0 on there and it becomes 8,000. Try not to get your zero or your commas in your decimals mixed up like I just did. Now, if we're at 800 and we slide back 1/10, 1/10 of 800 would be, it's going to let me in. There it is. 1/10 of 800 would be 80. Now, 50 is going to look very similar to 1, or is going to look very similar to 10. So when we multiplied 10 by 10, we got 100. When we multiply 50 by 10, we would get 500. Now, if we did 1/10 of 50, we would have 5. Okay, see how that pattern is going up? If we're multiplying it by 10, it's gaining a 0. If we're showing 1/10 of it, it's losing a 0. And that was true for all 4 of those. Let's do these ones here. Same exact task to do. So 500, what is 10 times as much as 500? Extra 0 makes it 5,000. Now, what is 1/10 of 500? So lose a 0. And we have 50. 90 is going to be very similar to 10 and 50. So if we have 90, 10 times as much as 90 would be 900. And 1/10 of 90 would be lose a 0, and we have only 9 left over. Great. What about 6,000? 10 times as much as 6,000, or 6,000 times 10 would be 60,000. And 1/10 of 6,000 loses 0. So instead of 3 zeros, it's going to be 2 zeros, and that gives us 600. And then the last one there says that 200, or number 12 is 200. So 10 times as much as 200, give yourself an extra 0. That gives you 2,000. And then 1/10 of 200 lose a 0 is 20. Okay, so try to practice those if you can. It should be on your practice work today for your homework. Let's look at number 21. For 21A through 21C, choose true or false for each sentence. So I would like to know, is 600 is 1/10 of 6,000. Is that true or false? When we're doing 1/10, we need to get rid of a 0. So if I get rid of a 0 there, it is 600. So that is true. And then the next one, 21B, says 67 is 1/10 of 6,700. So we're doing 1/10 again. We need to get rid of 1 0, but what I see left over now is 670. So it's not 67, it's actually 670. So that one is false. And then what about 21C? 1,400 is 10 times as much as 4. Well, if it's 10 times, we need to put an extra 0 on the end. So then it becomes 1/4. 400, and that is the number that we started with, so that is true. All right, let's look at the next skill. Place value whole number digits. So what you want for this one is you want to try to remember all of your place values. So if I did a quick place value chart, I could do, let's go up to millions. So we have millions, then we have 100,000, then we have 10,000, then we have thousands, then we have hundreds, then we have tens, then I can't spell tens, then we have ones. Now I'm looking ahead at some of these and it looks like I need to go up even higher. So let me make this a little bit smaller. I guess we'll just start right there. Before millions would be 10 millions, and before 10 millions would be 100 millions. I don't see any of the numbers in the billions. So those are our basic place values that we'll be working with in 5th grade. And this was part of lesson 2. So let me see if I can get it all in there. I'm trying to make it really small so it all fits. And I spelled 100 wrong. Fix that. HUNDRED, 100 millions. So if I look at this, we have ones. That goes way over to the right. We have tens. That's next. And that goes under the tens. We have hundreds. Whoops, and I need numbers. Come on, Witkowski, pull it together. We have hundreds. Then we have thousands. Then we have 10,000s. I like how the words get longer, so it leaves me more space. Then we have 100,000s. Then we have millions. This one I might have to make smaller. So millions is going to be 6 zeros. And I am going to have to make that one a little bit smaller, but it still looks nice under there. Then I have 10 millions. So 10 and then 6 zeros. Don't forget your commas in the right spot. And then I have 100 millions, which would be 100 and then 6 more zeros. So 8 zeros altogether. Okay, so now that I've written those out for you to see, I would like to find the value of that. So we need to take the place value and multiply it by the number in the underlined value. So the first one, it's actually number 2, has a 4 there. Let me switch to blue. So I'm going to write a 4, and then I notice that it's in the thousands place, so it's worth 4,000. Okay. The next one is a 1, and it's in the hundreds place, so it should have 2 zeros after it. The next one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is in the 10,000s place, and so it's got a 9 there, so it's going to be 90,000. The 3 is in the 100 millions place, so it's going to be 300 million. Oh, I almost don't have room for all my zeros. Start it over a little bit further. 300 million. And now I'm going to go a little bit slower for these last 4 because I want you to try to say it before I say it. So the 4 is worth how many? It's worth 10 million, so it's in the 10 million, so it's worth 40 million. What about the next 4? Oh, trying to trick us. 2 4s in a row. It's in a different place value. It is in the 100,000, so it's worth 400,000. The next one is a 9, and which place value is it in? And then how much is it worth? It's in the 10,000s, so it's going to be worth 90,000. Same as that one up there. And then the last one is a 4 again. They love the 4s for this. And it's in the 100 million, so it's 400 million. Notice how it changes depending on its place value. It could be worth a lot or it could be worth very little. So that is place value. Be sure to practice that in your homework tonight. We have, with place value, we also have ways of writing it. So what I'd like to do when I have the expanded version, which is what you see for number 6, is I like to try to read it all out loud so that I can hear it. The directions say write the number in 2 other forms. So we have expanded form, we have standard form, and we have written form. So those are the 3 ways. They've given us one. We have to come up with the other 2. So first, I'm going to find the standard form of this. I see 8 times 100,000. So that would be 800,000. Plus, and I'm doing this for my own sanity. I'll show you how it all kind of lines up here in just a second. Plus, we have 4 times 1,000. So that's 4,000. Plus, we have 6 times 1, and 6 times 1 is 6. So now I can see that's going to equal 800, 4,000, 6. And I want to make sure that my numbers are in the right spots. That's why I like to do it. I like to do the math first, because that way if I end up with some empty spaces, I know that the 0 goes in the empty space. All right, let's try to put it in written form. So we have 804, that's the first section, 804,000, then your comma, and then what's left over? 6. Let's look at number 7. Number 7 is already in word form for us, so I'm going to put it in standard form first. 7, actually, I'm going to put it in expanded form first. 7 times, it's in the millions place, so 1 million. Need parentheses. 7 times 1 million plus 20,000, so 2 times 10,000, because I want it to be 20,000, plus 30. So 30 would be 3 times 10, plus 2, which would be 2 times 1. Okay, so let me make that a little bit smaller so it all fits on there nicely. And now I can do the math for all of those, and I can write it in standard form. So 7 million, and then we need 20,000. So there's nothing in the 100,000s, but there is 20,000. And then there is 32. So nothing in the hundreds, and then 32. That would be expanded form. All right, let's do the last 2 there. We have 345,000. Ooh, these ones look this one looks a little bit nicer. So let's start with expanded form. We have 300,000 plus 40,000 plus 5,000. Now, I don't need to do anything for the hundreds, tens, and ones place value because it's already done for us. But now I need to make it look a little more like the expanded version in the first 2. So what I'm going to do now is take that number in that basic fact, and I'm going to do 3, parenthesis, 3 times 100,000 plus 4 times 10,000 plus 5 parenthesis 5 times 1,000. And that would be our expanded form. And perfect, fits on there nicely. Now I just need to put my word form on there because these two are technically the same thing. I just wanted it in the most expanded form possible, which would be the one with parentheses. But now I need to do word form, and word form would be 345,000. And that's it, because there are no numbers after the thousands place. So it's just 345,000. If we had more, our comma would go at the end. All right, let's do 119,003. This can be kind of a tricky one, but if you just take it place value by place value, you should be all right. So let's do it the same way we did that one. We have 100,000 plus 10,000 plus 9,000. No, I am so wrong. Oh, I am so sorry. It's 119 million 3. Oh, I'm so glad I caught that. All right. So we have 100 million plus 10, we have 100 million plus 10 million plus 9 million plus 3, because 3 is all the way down in the one's place value. So now what I can do is I can expand that even further. If it'll, there it goes. Let me click back in. So we have 1 parenthesis 1 times 1 million, 100 million parenthesis plus 1 times 10 million plus 9 times 1 million plus, oops, I forgot my parentheses, plus 3 times 1. Okay, that gives us that portion. And then we can write it out, and we have 119 million 3. All right. Hopefully that helps a little bit. There should be some practice of that on your assignment today. Next, we have powers of 10. And before I do these, I'm going to play this video for you. It's from Khan Academy. I love Khan Academy. I think he's very helpful. Doesn't like to go full screen when I'm using my Castifying app. So I guess let's do this. Quite a bit of lag when I do that too.
Let's think about what happens when we multiply by 10 and see if we can see some type of a pattern. So let's just start with 1 and multiply that 1 by 10. And this, of course, is equal to 10. Well, you knew that already. But let's multiply by 10 again. So let's do 1 times 10. And now let's multiply by another 10. Let's multiply by another 10. So what's this going to be? This is going to be 1 times 10, which is 10, and then that 10 times 10. So it's literally 10 tens, or 100. Now let's multiply by 10 again. So we're going to have 1 times 10 times 10 times 10 times 10. What is this going to be equal to? Well, we already know that 1 times 10 times 10 is 100, and then we're going to multiply that times 10 again. So we're going to literally have 10 100s, which we know is the exact same thing as 1,000. So what's the pattern here? Well, here we multiplied by 10 once, and we have 1 0. Here we multiplied by 10 twice, and we have 2 zeros. Here we multiplied by 10 3 times, and we have 3 zeros in our answer. Let's do it again, although this looks like a pretty clear pattern. Let's multiply by 10 4 times. So we'll start with a 1. We'll multiply by 1 10. That's our first 10. Then our second 10. Then our third 10. And now our fourth 10. Well, what's this going to be equal to? Well, it's going to be this thing times 10. Or this thing, I should say, times 10, or 1,000 times 10, which is 10 thousands. So let me write that, 10,000. So once again, we started with a 1. We multiplied by 10 4 times, and we got 10,000. 1 followed by 1, 2, 3, 4 zeros. Let me make that clear. We start with the 1. We multiplied by 10. 1, 2, 3, 4 times. And our product is 1 followed by 1, 2, 3, 4 zeros. So I think you see the pattern here, but there might be something you're craving. You're like, hey, Sal, this is a pain to do this repeated multiplication. I wish there was some type of operation that just did it for us. The same way that back in the day when you were doing repeated addition, where if you were saying 10 plus 10 plus 10 plus 10, you said, hey, this is the same thing as 4 times 10. This should be another thing for repeated multiplication. If I have 1 times 10 times 10 times 10 times 10, which is really the same thing as taking 4 tens and multiplying them together, because the 1 doesn't change the value. So 10 times 10 times 10 times 10, you're saying, hey, there should be some type of shorthand for this. And you're right. There is some type of shorthand for this, and it's called an exponent. So the same way if you take 4 tens and add them up, that's the same thing as 4 times 10. If you take 4 tens and take their product, this is the same thing as 10 to the 4th power. 10 to the 4th power literally means taking 4 tens and multiplying them together. Or you could view it as starting with a 1 and multiplying by 10 4 times. So this is also equal to 10 to the 4th power. This right over here, we started with a 1, we multiplied by 10 3 times, which is the same thing as taking 3 tens and multiplying them together. This is 10 to the 3rd power. This right over here is 10 squared, or 10 to the 2nd power. And this right over here, we just have 110 right over here. We just started with a 1, we multiplied by 10 once. This is 10 to the 1st power. And just so you know a little bit of the terminology, here 10 is our base. The base is 10. And this 4 that we have right over here, this is the exponent. The exponent. So given that notation, let's just do one practice. Let's think about what, I'll do new colors, what 10 to the 6th power is. And I encourage you to pause the video and think about it. Well, there's 2 ways to think about it. You could view this as taking 6 tens. So 10, 10, 10, 10, 10, and 10, and multiplying them together. So we multiply them all together. Or you could view it as starting with a 1 and multiplying it by 10 6 times. But either way, what are you going to get? Well, if you're multiplying 1 by 10 6 times, you're going to end up with 1 followed by 6 zeros. We already saw this pattern. So it's going to be 1 followed by 1, 2, 3, 4, 5, 6 zeros, or 1 million. So 10 to the 6th power is the same thing as 1 being multiplied by 10 6 times, or taking 6 tens and multiplying them together. And that's going to be equal to 1 followed by 6 zeros, which is this pattern we saw, or 1 million.
Perfect. I like that video. It is a helpful video. So if we go back to our assignment, move myself back up
in
here.
another video, we introduce ourselves to the idea of powers of 10. We saw...
I don't need you anymore. Thank you. All right, so if we have 10 times 10, the exponent form would be 10, and I'm going to make 10 bigger, probably. not. Okay, I'm going to make 10 bigger, right? We have 10, and how many 10s are there? We have 2 10s, so it is 10 with an exponent of 2, or the second power of 10. And then we need to write that in word form, and I just said it, it's the second power of 10. All right, and then looking at the next one, 10 is our base, so I'm going to make a big 10. And how many 10s are there? There are 4 10s there, so it is the fourth power of 10. Okay, perfect. Now, when we have this information, we can then find values of them. And just like the guy in Khan Academy said, I think he said his name was Sal, it's just like multiplying by that number. So here for number 3, we have 10 with an exponent of 2, or the second power of 10, which is the same as saying 10 times 10. And what is 10 times 10? 10 times 10 is 100. Very good. Now for the next one, we just did the second power of 10. So the second power of 10 we said is 100. So now we can do 4 times 100. And what is 4 times 100? 4 times 100 is 400. Then for the next one, number 5, we have 10 to the third power. So 10 to the third power is like 10 times 10 times 10. And what is 10 times 10 times 10? 10 times 10 times 10 is going to be, there we go, 1, and I see 1, 2, 3 zeros. So I'll put 3 zeros on that, and that gives me 1,000. Now I have 7 times 1,000, and 7 times 1,000 is how much? It is 7,000. All right, let's look at the next slide. Now we have some patterns here, and I want to remind you of a few things that you might hear while you are doing your work today. When you have 10 with an exponent of 0, or the 0 power of 10, it's even really difficult to say. It actually means 1. It means there are 0 10s, so it's just 1. So let me make a nice little chart. I will make it, oh, that's not what I wanted to do. I wanted to make this a little bit smaller. Here we go. All right, so let's make a little chart over here. And if we have 10 to the 0 power, that's going to equal 1. If we have 10 to the first power, that's going to equal 10, because it's 110. If we have 10 to the second power, that's going to equal 100. 10 to the third power is going to equal 1,000. And 10, what's it doing? All right, 10 to the fourth power is going to equal 10,000. I need to make it a little wider. And I think that's as big as we need to go right now. I did not put the exponents in there because I wanted to make sure it was done. So we said the first one was 10 to the 0 power. That looks like a 6. 10 to the first power, 10 to the second power, the third power of 10, and the fourth power of 10. So there is a little cheat sheet for you. So now if we do 12 times 10 with an exponent of 0, that's actually doing 12 times 1. And 12 times 1 is 12. The next one, because we're just going up in a pattern, is 12 times the first power of 10. Remember, the first power of 10 is just 10. So it's like 12 times 10, and 12 times 10 is 120. And that was one of the problems that you had for a warm-up on Seesaw. It was all about brochures. There were 10 brochures given to 12 groups, I think. So how many brochures were out? Then the next one says if we do 12 times the second power of 10, the second power of 10 is 100, so that's like 12 times 100, which would give us 1,200. And then 12 times the third power of 10 would give us 3 zeros, so 12,000. And then the fourth power of 10 would give us 4 zeros, so 120,000. Now, here's a little bit of a challenge. It says reason abstractly. 10, the third power of 10 equals 10 times 10 with a question mark there, or an N. We don't really know it, but we know that it needs to be 10 times 10 times 10. So how many 10s are inside that box right now? It's 2. So that would be the same as 10 times 10. Make it bigger. 10 to the second power, because there were 2 zeros there. That's kind of all crammed in there. So the value of N is a 2. All right, 2 slides left. One more idea that we need to go over. Multiplication patterns. So now we're going to start putting a lot of this together. So let's do parentheses first, just like we were talking about yesterday and Tuesday. So 6 times 6 is 36. That does not say 36, Witkowski. 36, and now we're doing 10 to the first power, so that means 110. 10 to the first power is 10, so 36 times 10 would give you 36, and 10 is 360. 9 is in the middle there, so we need to do 7 times 20, 7 times 4. I almost said the answer. 7 times 4 is 28. And now 10 to the third power, or the third power of 10, is 1,000. 3 zeros, right? So I need to have 3 zeros on 28. And then I'm just going to go back 3 and put my comma in. Number 10 says 9 times 8. 9 times 8 is 72. And how many zeros do I need? Because I'm multiplying that by 10 to the second power, or the second power of 10, which means 2 zeros. And I'm going to go back 3 spaces and put my comma in. Excuse me. The next one says 4 times 3 is 12 times 10 to the second power. The second power of 10 means I need 2 zeros. So I'm going to go back 3 spaces to put my comma in there. And then the next one, number 12, 2 times 5 is 10. And we're going to multiply that by the third power of 10. So we actually need 3 more zeros. And then that gives us 10,000. The next one says 2 times 8, and that is 16, times the second power of 10, so 2 zeros. That gives us 1,600. Number 14 says 6 times 5. 6 times 5 is 30, times the third power of 10, so 3 more zeros, 1, 2, 3, and that gives me 30,000. Then I have 8 times 8, which is 64, times the fourth power of 10. So I need 4 zeros here. 1, 2, 3, 4. I'm going to go back 3 spaces to put my comma in, and that gives me 640,000. And then the last one says 7 times 8. Oh, this is the hardest one for me. 56. 56. Yes, final answer, 56. And it says times the fourth power of 10. So I need 4 zeros again. And then I can go back 3, and that gives me 560,000. All right, we have 1 page left. And this is just a patterns page. So I need to know for number 4, what times 4 equals 28. And if you look down underneath, it gives it to you. So it is 7. 7 times 4 is 28. So now I need to know which exponent to put with 10 so that it is the right exponent and the right numerical expression to equal 280. So I need to add 1 0. That means I'm going to have an exponent of 1. See how easy that was? For the next one, it's the base of 10 still. It's always going to be the base of 10 for now. And I have 2 zeros, so it's going to be an exponent of 2. Miss Witkowski, where are you getting those 2 zeros from? Let me show you. 2 zeros right there. Now this one has 3 zeros, so the exponent is going to be 3. So I need to have a base of 10. And then my exponent of 3. Perfect. Now, what is 6 times 8? 6 and 8 went on a date and came back 48. So all of our numbers for this one are going to start with a 4 and an 8. Let me plug those in right now because that's this nice thing about a pattern is that there are going to be some similarities. Now, for the first one, we are multiplying 6 times 8 times the second power of 10. So I need 2 zeros, and that gives me 4,800. Notice how that looks very similar to the one that was over here, just a different product to begin with. Okay, then the next one, it says 6 times 8 times 10 to the third power. So I need to put 3 zeros, and that gives us 48,000. Notice 3 zeros gave us 28,000 there. And then for the last one, we need to multiply times 10 to the fourth power, or the fourth power of 10, or 4 zeros, and that will give us 4,000, or 48, one more time, 480,000. All right, now for the last one, we need to know what times 4 equals 16. Well, if you look below, it kind of tells you. So it's 4 times 4 equals 16. And just like the other two, it's going to be a pattern. So both of these, all 3 of these are going to start with 1,600. And then we need to figure out how many zeros are going to be on this product. So, whoops. There we go. So I don't know how to let me in. There we go. Okay, so 4 times 4 is 16 times the second power of 10 is 2 zeros. So that gives us 1,600. The next one says 4 times 4 times the third power of 10. So 3 zeros, and that gives us 16,000. And the last one is times the fourth power of 10. So 4 zeros, and that gives me 160,000. Hopefully, some of these were just a good refresher. Hopefully, you learned something new or you were reminded of something and that you will be able to apply it to your homework for today. All right, enjoy and good luck. Let me know if you have any problems.